Hi, I am Ramakrishna, working as Assistant Professor in the CSE department at VIGNAna JYOTHI Institute of Engineering and Technology, Hyderabad. So today we are going to discuss about the software engineering concepts. In this, we are going to discuss about the modeling with UML under the design part. So we'll see the importance of the modeling. So when you take the software development life cycle, so under that, the second phase of that life cycle is modeling design part. So this is very important to the user, to the developer, and to the tester, for everyone. So with the help of a modeling, you can understand the complete development of the project, and the blueprint of that project is easy to explain, easy to understand. So that is the when you take a software development life cycle phases, so 35% of the contribution you are getting from the design phase only. So that is the importance of the modeling. So when it comes to modeling, why it is important? So first we'll see the definition of the modeling. So it is a process of the creating a simplified representation of the real world system, that is to analyze, understand, and to improve it. So for that, why the modeling is very important. So it helps in visualization, and also you can take the decision making and for problem solving in different situations, different scenarios, and also it will reduce the cost and risk before real world execution. So you can prepare a sample template by using the modeling and by using the design related tools. So you can execute that sample, and if it goes well, then you can go with the real world execution. So this we are applying in everywhere in a real-time applications, this modeling. And here this modeling you are applying in different fields. So nowadays in automobile field, or mining, or aircrafts, building, software, everywhere you are applying, in construction department, everywhere you are applying this. And especially in the electronics department also, for microprocessors, for circuit design, we are using this modeling. Also for entertainment industry, they are preparing the storyboard before they actual shoot the what is happening on the sets. So also in the business, whenever you want to explain about the product to the customer, first you can take the help from this modeling, you can design it, and you can convey to the customer with the help of this very easily without any execution. So in the stock market analysis also, we are using this particular modeling. So these are the various applications you are using, and you are applying this modeling in those departments. And we'll see the next one, modeling with the UML. What is UML? It is a unified modeling language. So the definition of UML is, it is the language for, it is for constructing, it is for visualizing, it is for documenting the artifacts of a software intensive system. So what is the purpose of UML? It is not a programming language, it is a modeling language. To know the application structural and behavioral concept, will use this particular design part. Also to standardize across the various departments, so we'll use this one. Also, but with nowadays, if you see this, one single model is not sufficient to represent any type of application, because some applications may be very complex. So due to that, we are going with the various types of models. So all those different models you can express with the help of this particular unified modeling language, and you can represent any type of complex system. So just like you take a shopping cart, that is like Amazon or Flipkart, so there you can see that how they are accessing the items, how they are taking the offers, how they are paying amount after selecting the product. All those things will be clearly step by step will be represented by using the UML design. And here, why this UML? So just now we have discussed UML is a language for, it is used to visualize. For you can visualize it, and you can explain to the customer very easily, and you can specify the things, what exactly it consists of, the main elements, whatever it consists in the product, that you can specify. Also, you can construct it with the help of a tools, design tools. You can construct it and you can easily explain to the customer if any kind of application, whether it is a simple, moderate or very complex application, also you can do it with the help of a UML language. And finally, you're going to document these, whatever you have done for this development, all those will be documented. So finally, these are the main components of the UML. And it is why UML? It is providing a common language for the developers, designers, and also for the stakeholders. Stakeholders means here, so whoever involved in this development, that is from the scratch, right, from the beginning to end. Also, the end users will come under stakeholders only. And also, it helps in breaking down the complex software systems into manageable models. So here it enables the efficient software design before actual coding. So here what we are doing is, suppose you want to develop a banking application. Suppose you want to develop a automated teller machine. So what is the purpose of this particular machine? Yes, the customer can, without coming to the bank, he can directly go to the ATM room and he can, with the help of a debit card, he can take the money easily with small steps. If you can explain all those to the customer by using this particular UML, that will be very easy to withdraw money just by having a 2 or 3 steps here. So for this process, what exactly needed? So yes, the account is required and the amount will be available in that account, and this should be mapped with the database, and that is mapped with the to access the amount, to access the account. So one debit card is required for that. So whatever the transaction he is doing with that ATM machine, all those you can represent with the help of this particular UML, Unified Modeling Language. So under this modeling with UML, first you are doing the visualization. That is how the user is interacting with the machine, how it starts, what is the step-by-step procedure. All those will be explained clearly with the help of UML diagrams. And it is very easy to communicate between the users and between the user and machine also. So second one, specification. Yes, you can specify it even though it is unambiguous, even though it is very complex, even though it is incomplete, that you can specify it clearly before you start the implementation process with the help of a design. And also you can construct. So with the help of a UML, you can have a blueprint with the software, with this rational row software or star UML software. So you can map these design part with the current languages, object oriented languages like C++, Java, Python or C#. All these languages you can connect, and also you can generate some part of the code with the help of this design. And coming to the documentation, whatever you're doing, everything you should put it on the paper. That is very much required. Why? Because this software development is not, you're going to do it but at one stage. You're going to complete this process in multiple stages. Maybe after 3 months or after 6 months, again you're going to extend this product, or you're going to modify something, or you're going to change something whenever the customer is facing any issue. So during that phase, he need the exact picture of that particular implementation and design. That's why we are going to document everything here. So for that, we are taking the artifacts. Artifacts means pieces of information you have collected from the various sources. That is the requirements gathering, and also your where you are fitting all those requirements in the architecture and the overall design part, and whatever the source code you have written, that is done by the developers, and whatever the test cases you have written to test the product. All these things need to be documented. Then only it is possible to extend the project again, like after 6 months or after 1 year. And next here, these are the various industries are implementing the same UML modeling concept for understanding the product, for explaining to the each department, also for conveying to the customer easily. So these are the different industries. That one is like ERP, enterprise systems, or banking and financial system, telecommunications, healthcare and medical electronics, defense and aerospace, retail and e-commerce, scientific research, web-based distributed service. So everywhere nowadays you are applying this particular design part and you are using the UML. And coming to the modeling with the UML, the main concept here is the structure. So how it looks like, the conceptual model of the UML, also call it as the building blocks of UML. When you take a UML building, it is divided into 3 floors. First floor is things, second floor is call it as relationships, and third floor is diagrams. So with the combination of all these three only, you are able to use the UML language to develop something or to design something or to any complex system. You can handle it very easily. So the first component is the things. So things are the just like a real world objects. Whatever the objects you are using in your product, in your application, all those you are going to divide into mainly two categories. One is like structural things, second one is behavioral things. Along with these things also we have another two categories, we'll see in the next slide. And coming to the second component, relationships. Whatever the things you have identified like structurally, behaviorally or some other categories, then you are going to make the relationship between these objects. So for that, we are going to use the different elements under this category, relationships component. Coming to the third one, diagrams. After making the relationship between the things and relationships, then it will form a diagram. So here we are going to use multiple diagrams. In the first slide we have discussed, this one will be expressed at various levels because it is not a single level you are going to express. So why? Because here with the help of UML you can solve any type of problem, whether it may be easy, moderate or complex. Especially for the complex problems, you can solve it very easily with the help of this particular UML. So for that, what we are doing is simply we are going with more diagrams. So this UML consists of 9 UML diagrams. So with the help of 9 UML diagrams, you're going to express it in different levels. And coming to the things, the first component. So when you see this right side image, so this is the classification. So these three are called it as the building blocks of UML. So there are 3 building blocks: things, relationships, diagrams. So when it comes to things, they are divided into 4 categories. One is structural things, second one is behavioral things, third one is grouping things, and fourth one is annotational. Coming to the first category, structural things, they are static part of the system. They'll never change the structure. Everywhere, in every place, in every application, in every diagram, always it looks like the same graphically. So they are called it as the structural things. So we have examples like a class, interface, use case, component, like this. All these examples are static elements. And coming to the second category, behavioral things, where here the behavioral things are like always changing its behavior based on the requirement and based on the situation. So here these are all like comes under dynamic aspects. So here what it is doing is whenever it is interacting with the system, then it will change the behavior. So there are 2 examples under this category. We have state machine and interaction, also call it as a object message. Coming to the third category, grouping things. So wherever there is a possibility of organizing, like you know that in the OOPS concept, object oriented programming system, there is a concept called object and class. So there you will identify the various types of objects, and there wherever there is a possibility to grouping, so then it is called it as a group of objects or call it as class. So likewise here also will group the objects, will group the classes also, and that organizing elements example is called it as a package. A package is a collection of classes you are grouping together and you are arranging it as a group element. Coming to the fourth one, annotational element. So annotational thing is called like along with the actual representation nowadays, to understand it very easily, to convey it to the customer very easily, we are adding some extra decoration that you are doing with the help of annotational things. For that, what we are doing is simply you are adding some comments to that with the help of a note item, so that you can easily understand by reading that note, by seeing that particular comment. You can understand the picture very easily, you can understand the design. So likewise we have 4 categories under the things. And coming to the second component or second building block for your UML is the relationships. Once you identify the various kinds of objects like individual objects or group of objects, then here you're going to make the relation between the each object. So that you're doing first with the help of a relationship called dependency. So dependency is like one object is completely depending on the other object. Without that object, second object, it does not exist. So wherever there is a chance of that type of relationship, there you can apply this particular dependency. And coming to the second relationship, it is called it as a generalization. It is also called it as a parent-child relationship. So here it is just inheriting the properties from the parent. So whenever it is inheriting some properties from the parent to the child, there you can simply apply this relationship called generalization. This topic you have already studied in object-oriented programming system. There you have studied it as an inheritance. The same concept you are applying with the help of a relationship called generalization. Coming to the third one, so the association, this is the general structural relationship. This you can apply between any kind of objects, and there is a cardinality when you apply this particular relationship. That is called, there is a one-to-one communication, one-to-many communication, many-to-one communication, and many-to-many communication. So likewise, wherever there is a possibility, you can apply the relationship between these objects. For that, you are using association. This you can apply everywhere easily. And coming to the fourth relationship, realization. This will be applied only a family of elements. Family means here there is a relationship between the class and object, because a collection of objects are called it as class. Also like that, we have some elements. So between the class and interface, between the class and component, you can apply this type of relationship, realization. So this we are using a class implements an interface. There you can apply this particular one. So all these interactions you can see, like example in the ATM system. So whenever the customer is interacting with the ATM machine, so automatically this will be having a connection, association with a banking server database. With the help of database only, like many customers are interacting with one database, or else one customer is interacting with one database, or else one customer is interacting with many databases, like he is using different cards to withdraw money, or like one customer is interacting with the many customers are interacting with the one server. Likewise, you can apply this relationship here. So and this is the second component or second building block of the UML. Coming to the third component or third building block of UML is diagrams. Once you find the objects, once you make the relationship between these objects, that is called it as a diagram. With the help of these diagram, now you are able to clearly explain the what exactly you're doing with this particular functionality, what exactly you're going to explain to the customer, that you are taking the help from with the help of these UML diagrams. So we have two categories, structural diagrams and behavioral diagrams. So coming to the structural diagrams, I told you just now, structural means it will never change the structure. Always it looks like the same in everywhere, every diagram. So they are called like structural diagrams. So four diagrams comes under this category: class diagram, object diagram, component diagram. Also we have a deployment diagram. And coming to the behavioral category, like always based on the situation and based on the interaction, it is changing the behavior. So here we have another 5 diagrams comes under this category, that is use case diagram, sequence diagram, collaboration diagram, and activity diagram, state chart diagram. These 5 comes under this behavioral diagram. So likewise we have totally 3 components, 3 building blocks we have for this UML. And under the things just now we have discussed, there are many elements, like we have 7 elements comes under structural category. It is comes under static part of the system. So here what are the stable components we have? First one, class. You all know that you have already studied in object oriented programming system. So class, how it looks like graphically, it is divided into 3 parts. So first part is like a class name, second part is indicated indicating that class attributes, third part is indicating that class operations. So the same way you are writing the OOPS C++ or Java programming. So like you'll start with the class name, you'll start with the public variables, member variables, and also you'll start with the declaration of member operation. The same representation you are doing that in that rectangle box with three compartments. Coming to the second one, interface. Wherever you want to implement something that you are representing with the help of I and followed by that operation, graphically it looks like a circle. And this you are doing. So whenever there is a chance of implementing the function, that you can represent with the help of interface. Next, third one, use case. So here, whenever you want to describe the system functionality from the user perspective, then we'll represent it with the help of a use case. It looks like, how it looks like graphically is, it is ellipse shape. In that you can mention, suppose you take an example like ATM. In the ATM, what is the major functionality? You're going to withdraw money. So withdraw money is the major use case you can represent. Also you can check the balance, second use case. You can take the mini statement, third use case. You can transfer the money, fourth use case. So likewise, the system functionality will be represented in the customer point of view with the help of use cases here. So that you are representing graphically is called ellipse. Then fourth one, component. So component is like a collection of classes you are organizing and grouping it together, and that element you are representing is called component. So this component is a rectangular box with two tabs. So that you are representing. So whenever there is a chance of representing it a physically deployable part of the system, then you can use this particular component under the structural things. So here you take examples of all these. So class, interface, component. So for this, we just now I told you, for depositing, for withdraw money, we'll use all these attributes. Account number is required, balance, how much balance is there in the account, and you're going to use the methods like deposit and withdraw. And when it comes to interface, so there is an interface to perform the transaction. You need a third party like payment gateway to process the transaction, to process the payment, or to validate the transaction. You need this particular one. Coming to the use case, so to transfer the money, that is from one account to the another account, here again you're going to use this particular use case. And component, so everything will be developed it as a web application. So it is divided into front end and back end. So whatever you are entering like pin number or something amount or some other options, that is you are doing with the help of a front end part, and this will be verified with the database, that is called backend. So it's a combination of front end and back end. You're going to develop a one web application. So that is about the examples of the online banking system for structural things. When it comes to behavioral things, so we are going to represent the system with interactions. So how it is interacting, one user, how it is interacting with the machine, that you are going to represent here. For this, we are using two elements. One is state machine, second one is interaction or called object message. What is the use of this state machine is like you're going to know the status of the particular event or a particular transaction when you take an example of banking application. So suppose, is it ready, or it is in waiting state, or it is in processing state, or it is going to end the operation, that you will know with the help of a state machine. So for that you are using this behavioral thing. And coming to the second one, interaction. Whenever the two objects are interacting with each other, that you can represent with the help of a message, that is solid line with arrow. So this you are doing every time between the objects or between the classes. That is also call it as a object message. And coming to the next one, when you take this particular example, order processing system, just now we have discussed what is the status of your order whenever you book anything in the online. So you can have the status of that particular order, whether it is packed or whether it is delivered or not. Everything will be clearly known with the help of this particular element. Likewise, you can have the interaction. Whenever the customer places an order, you can verify the stock, you can make the process payment, you can confirm the order. All these things you can do it with the help of that particular interaction message. So these two are the examples of the order processing system in the behavioral category. And when it comes to grouping, how it looks like, I told you the only one example under the grouping thing is package. So wherever there is a possibility of combining the elements like objects are grouped into classes, and again you can combine the classes into package. So how it looks like graphically, it is a tabbed folder. So here you can run at a time more than one or two classes. You can combine it with the help of a package element. And the example is like a user management. It contains like classes are librarian, member, and admin. These three persons will act this particular user management. So all the three can handle this in different places. So all at the same time. So when it comes to a package name, book management, so it consists of a classes are like book, also have a author, also have a category. So these three classes will be run under a book management package. And coming to the last category, fourth one, annotational thing. I told you along with the implementation part, along with the design, if you add something more that is like beautification, then the customer can understand very easily without explaining anything. So that you can do it with the help of this particular element, and it is called it as a note item. It is graphically looks like a folded one side, right side it is folded. So paper folded element it is. So here this you are doing for adding the documentation, like you can add some comments. Like whenever you write the program, first you'll start with the heading, like this is the program for writing so and so, like that. So here also you're adding some comments, descriptions, or some extra info you're giving, so the user can understand just by seeing the picture. So that explanatory part will be provided with the help of note item. And also this will be used to clarify the complex interactions or design decisions. So especially when you take the example e-commerce system, so here this will be useful like extra mechanism, like this process includes the discount validation before you check out. This function needs the admin approval for modification. So likewise that extra information will be added, then user can understand just by seeing that note item very easily. And coming to the second module or a second component or a second building block of the UML is relationships. So there are four basic relationships we have to connect these objects. One is dependency, second one is association, third one is generalization, fourth one is realization. How it looks like graphically, dependency, it is a dotted line with arrow. Whenever the one object is totally dependent on another object, without that object the second object does not exist. That so there you can apply this particular dotted line with arrow, that is dependency you can apply. So when you take the example hospital management system, a doctor class depends on a prescription class. Why? Because based on the prescription changes, that is completely when it will be changed based on the doctor's input. And coming to the association, so here in the association we use a relationship like it's a bidirectional, you can use both ways they can communicate, or unidirectional, you can use only one way you are communicating, you are not expecting any acknowledgement from the other user. So both ways, it is just a solid line, actually solid line with the arrow you can use if you want to go with a unidirectional, or you can just remove the arrows, that is a bidirectional association. This will be applied everywhere whenever you want to communicate, like one-to-one communication, or one-to-many, or many-to-one, or many-to-many. Simply you can apply this particular relationship association. Then third relationship is generalization. So here generalization we are going to we have already discussed in the starting part. So that is wherever there is a inheriting the properties from parent class to child class, that you have studied in object oriented programming system, so that is called with the help of inheritance. So there you can apply this relationship. So it is like solid line with the hollow arrow, that is you are using for graphically to represent the elements. So here this is the parent class is also called as a superclass, and child class is also called as a subclass, or else base class, derived class. Parent class is base class and child class is derived class. So this you are doing. And if you take the example vehicle management system, so here car and bike inherit from a vehicle superclasses. So this comes under vehicles only. One is car and second one is a bike. Coming to the fourth relationship, realization. So this relationship defines that where one entity implements the behavior of another. So here it will use the like interfaces. Wherever there is a implementation part, you need to explain it more with the help of implementation. There you can use this dotted line with the empty arrowhead, so that you can use it here, also called as a hollow arrow. So here, so wherever, like example, when you take a payment gateway interface defines, that is methods that credit card payment and PayPal payment classes, these two must implement. So I want to implement this, so that you can do with the help of this particular realization relationship. So these are the four basic relationships you are using to connect these objects. And the third component or the third building block of this particular UML is diagrams. So we have totally 9 UML diagrams. They are divided into 3 categories: structural diagrams, behavioral diagrams, and interaction diagrams. So structural diagrams will represent the static part, and behavioral diagrams will represent the dynamic part, and interaction diagrams are like it will focus on the flow of control and data exchange. So these 3 categories will help you to design the product, will help you to solve the any type of complex problem under the design part. And this is the picture of the complete modeling with UML, or conceptual model of UML, or building blocks of UML. So under this category, diagrams are divided into again 3 categories: structural, behavioral, and interaction diagrams. When it comes to structural, you have a class diagram, component diagram, composite structure, deployment diagram, object diagram, package diagram, and profile diagram. Coming to the second one, interaction category, whenever the user is interacting with the machine, the flow of control and data exchange will be done with the help of these diagrams. They are calling it as communication diagram, interaction overview diagram, sequence diagram, and timing diagram. And the last one is behavioral category. So under this behavioral, you have a use case diagram, activity diagram, and state machine diagram. So these are the diagrams now we are going to use to develop the application. You are going to design the product with the help of these, because in the first slide we have discussed any complex type of application can be represented at various levels by using the various types of diagrams. So that's all about for the today. So in the next video, we'll discuss about the diagrams, each diagram. What is the speciality of the each diagram, how it will help you for the simple application, for moderate, for complex application. So that we'll discuss in the next video. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.